So from Math Project, you guys all know Deb Stetson. And there's Fran Gibson from SCOE, which you guys all know well. And you guys all know Jerry Keskes, our PLC coach. And Kathy Remley, our K-12 mathematics coach. And then our new members of our team today. So Carrie is a part of the Math Project. She's a kindergarten teacher and a vice principal all at the same time. Is that cool or what? That's like
got her out of her school to come today here.
I know. We should have. So thank you, Carrie, for joining us today. And of course, Rick West. He's part of the Math Project. Rick actually has been teaching me math since I was a kid. So I'm honored to be on this side of it and having him join our team. He's one of my heroes of my life. So thank you for joining us.
We're going to do something a little bit different this year than we did last year. Last year we worked a bunch on how to get kids talking and that we're playing kid detective. So today and the next 2 days we're going to be working on what does it really feel like when you're doing math and you're doing the standards for mathematical practice that we're trying to infuse in our classrooms. So the morning we're going to actually do some math for ourselves from a learner's perspective so you can feel what it feels like when we're actually trying to do standards for mathematical practice for ourselves, all right? So that may be a little different than a lot of professional learning about mathematics teaching that you've done before. So that's what we're going to do for ourselves, and then we'll follow that because Carrie and Rick and I are going to be modeling some strategies that you could use in your classroom. So we'll follow that with a debriefing discussion about, so where did you catch yourself doing some mathematical practices and what was it that prompted you to do that? So we'll follow, you could be thinking about that while we're doing the math. Because I want you to at least think about 2 things, the math and what made you do that. All right, so we'll do that with the debriefing. And we'll have a break in between there, 9-ish. Okay. Then we're going to actually look at some stuff about the number line and fractions to kind of wrap our brains around what would it feel like if I was doing that sort of stuff in some content that I might teach. I know not everybody teaches fractions, but a lot of folks are doing number lines, so we'll be talking about that. And we're going to talk about a teaching cycle to make overt some of the stuff we've been doing with fractions on the number line.
How many people could think of a 1-digit number? That's, you know, it's going to start off reasonably nice. So in your heads, take a 1-digit number, preferably not 1, but it works with 1. All right? Take that number, multiply it by 9. How many people now have a 2-digit number? Take those 2 digits and add them together. You can use your fingers if you want, it's okay. And then subtract 4. And now comes the complicated part. If you have 1, change that to the letter A. If you have 2, you're going to change it to the letter, everybody? B. And 3? C. And so on. Okay? How many people have a letter now? All right, now I'm going to go a little faster. This is like you know, across the curriculum head problem. I want you to take and think of a country somewhere in the world that starts with that letter. And then I want you to take, if you spelled out that country, take the last letter and think of an animal that starts with that letter. And then I want you to take, if you spelled out, you know, that animal, not its name like Fred, the type of animal. Okay, take the last letter and think of a color that starts with that letter. All right, we got it? Now, here's what I want to do. I want you to show me on your finger how many orange kangaroos there are in Denmark. No, wait a minute. Oh, somebody said koala. How many people got an orange kangaroo in Denmark? What? Did I do something wrong? Let's try that again. So, what? Should I go back a little bit? The last letter of the animal?
Turn it into a color.
Yeah.
Now what?
And then I said, how many orange kangaroos in Denmark are there?
And we were supposed to raise our hand because we were all supposed to have it.
Well, some people. I thought at least one person. No one? Well, hold on a second. All right. One digit number times 9 in your head. Take the sum of the digits. What do you have, everybody? 9. Whew. All right. Oh, I just messed up.
Well, see? That was you, not us.
It was me. I knew it had to be. Let's try this again. All right. Subtract 5. I'm not 100% this morning. No, not O. O is not that letter of the alphabet. I'm supposed to hold this up, huh? All right. Now how many people have a number? We're off to a good start this morning.
Because you said subtract 5 this time.
Yes. That works better? Yes. Now, how many people have a letter now? Oh, okay. Whew. All right. Think of a country that starts with that letter. Spell it. Kara, the introduction. I've just blown your whole introduction. I'm not your hero anymore, am I? All right. And take the last letter in the spelling of that country and think of an animal that starts with that. Spell that. Now, how many people have an orange kangaroo in Denmark? Hold your applause. All right. If you give me some artistic license, everybody, what shape do you see up there? And the dimensions roughly? All right. I'm doing better now. That's why I must have subtracted 4 instead of 5. Anyway, some reason. All right, let's see. So how many people can picture, like a brick tile? If those are all squares, they're all the same size, how many people can picture a brick tile that covers exactly 2 of those squares? People can just imagine that. One that would sit just maybe across those 2. Okay? So what I want to do is I want to take those brick tiles that are all the same size, and I want to try and cover that whole thing.
How big are they?
They're all like 2 by 1, so they would cover 2. They could cover 2 this way or 2 that, doesn't matter, but they all cover 2 squares. How many people think that I could cover that completely with no? Oh, how many people think no, that's not possible? Talk in your groups for a second and come up with an argument why that's not possible. Somebody walked in the room right now and told you could cover that thing with those bricks. How many people would be skeptical? Does somebody have a reason why? Anybody hear something at your table as a reason why? Is that a hand up, Francie? I didn't know.
Okay, sure. Because there's 25 blocks.
How many people know where she's going if she says there's 25 blocks?
You're at 5 by 5, and a 1 by 2 is covering 2 at a time, and 2 is an even number.
Very nice. So, how many people heard? How many people heard a lot of that? Okay. So, I'm curious. Show me on your fingers if you tried to do this. If somebody's improving my artwork, I like that. If you tried to do this, show me on your fingers how many of those squares would be uncovered. How many people agree with 1? Now, this is kind of an important moment in all this because one of the things we're about is reasoning. How many people believe that, if you kind of use Francie's argument, that even 1 left over, that it wouldn't matter if you tried to do this for thousands of years, it could not be done? How many people are good with that? Okay. We're going to, pardon me?
Well, it depends. Can you hang a tile off the side?
Yeah. You can't hang anything off the side. You can't overlap them. So with no tricks, okay? All right, so here's what I want to do. If I took, let's see. We have one special decorative tile that's a 1 by 1. If I took and I placed, tell me again now, why can't you cover this? It's because there's how many squares? 21. Which is what kind of number? And if we did 1, you guys are good. You didn't tell me this was like these were the chorus teachers too. So how many people think there's kind of that area thing that's just not going to work? So I'll help you. There's a decorative tile. What if I put that decorative tile right here? Now how many people think you could cover it? Without trying it, without doing it visually, can somebody tell me why you think you can cover it now? Why do you suspect you can? I'll take a hand. Somebody, I'm sorry. Yeah, Deanna. How many people agree? You take one out. It's now how many? 24. Which is? Even. Go ahead, see if you can do it on your papers. Or there's whiteboards or anything. You can use scratch paper. Or
Graph
you can just
paper.
look up there and kind of visual it, whatever you want to do. See if you can do it. So how many people were able to do it? How many people think, 24, I was hoping I could do that. Let's see. Would somebody like to just kind of volunteer how they did it? Or get me started at least? Dawn?
Start in the left, go across to the second one, go to the next one, down. Keep going all the way across.
Like that?
Yeah, there, go down. No, yes. And do the, this is hard to
I
say
know.
it.
How many people think it's tricky to give Rick directions?
All right,
And that
start
was
at the,
tricky to give directions.
all right, start
not
at the
just-
top left, start at the top left again. Now, right there, go across the way you did before, go down to the next set, go down again.
Here?
Yes.
Like
Go
that?
across, yes. Follow the next set, the next set. Okay, now go ahead. Go back up to the top.
I'm getting nervous.
How many people think they know how she might finish it?
So go back up to the right. Go ahead and do that pattern all the way down that row. And now go back over to the other two and go down there. And you're done.
Very nice. How many people think there are other ways? And that would be a completely different problem, but we're not going to do that. So I want to draw this again. Oops. So if we did the same sort of thing, what if this time I put my decorative tile right here? How many people think Deanna would say, there's 24 squares left? That's true? How many people think you could probably do it now? Because there's how many squares? And that's? Go ahead. Really fast people here. So if you already found one way, go ahead and try and find another way. How many people have already found at least two ways? How many people have found two ways that didn't work? Oh, all right. Yeah, I didn't say two ways that worked. I don't know. I haven't done this problem before. I'm like, I'm working on this. I figured out how to ask questions, not answer them.
I see a lot of persistent people.
Oh, that's right. Persistence is good, huh?
It is a good thing. How many people are having a little trouble finding a way to get this done? How many people, show me on your fingers how many ways you've tried and it didn't work so far. Let's look around the room. That's a lot of folks. Huh. So I want to ask you a slightly different question. Way back when we first started the problem, even up here on the document camera, how many people agree that one we were able to cover with the rest of the bricks? Wait, how many people agree we were able to cover with the rest of the bricks? All right, just making sure I was in the same room you guys were. So we were able to cover this one. And before we even put the decorative tile on there, before that was even there, we had a slightly different question. We didn't have that decorative tile there, and we had all 25. And we asked you guys, how many people think we could cover it with 2x1 bricks? How many people remember that question? Could someone raise a hand and tell me how we decided the answer to that question? How many people remember that? All right. Anybody willing to share? How did we decide the answer to that question? We just had all 25 and we wanted to know if we could cover it. Wait a minute. Everybody, could we cover it? Yes. So how many people like me heard two answers right there? How many people think I've been less than clear about what my question is? All right, I'll try again. I could even put a new piece of paper so I don't screw this up. I'm trying to have you remember when we had all 25 squares, how many people think my artwork is even worse than Rick's? Whoa. Do I have 25 squares? We'll count that one, okay? All 25 squares, and we're trying to cover it with those guys. How many people think it's not coverable? Could somebody raise a quiet hand and tell me how we knew for sure it's not coverable? Because you guys didn't just I know you just didn't go pop, 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 pop with bricks in your head. How did you know for sure it was not coverable? How did we decide that again? Oh, I got a quiet hand from Lori. I got a quiet hand from Vanessa. Quiet hand from, is that Deanne? Quiet hand from, oh man, this popcorn is increasing. This is awesome. I'll go back to Lori.
25 is an odd number, and you're trying to cover it with even numbers.
How many people agree we had that mathematical argument to save ourselves from looking for forever? All right. Well, so now I'll come back here to this question. Of these two things, oh, I almost walked out of my shoe on top of that thing. Not graceful, am I? We had this decorative tile here, and you guys did that. And we had this decorative tile here, and you guys have a bunch of stuff on your papers. I'm going to ask you to vote for which one you're more sure of. So the question's going to be, are you more sure of this one that you can cover it, or are you more sure of this one that you cannot cover it? How many people understand my question that I'm about ready to ask? Ooh, that wasn't everybody. Can anybody restate my question? Oh, I should know this person's name. She's a friend of my other friend, Kim. I forgot it. Deanna. What's my question, Deanna?
Your question is asking us which one of those two grids are we more confident we can cover with 2x1 squares, tiles?
How many people agree? I'm trying to ask you about if you're more confident that you can cover that one or that you cannot cover that one. How many people agree? I'm trying to ask you about that. All right, so
Okay.
how many people? Yeah, Rick.
Yeah, so suppose you had two people. One person said, the one on the left, you can't cover it.
Cannot.
Cannot. And another person said, the one on the right, you can cover it. How many people think they're both wrong? Which one are you more sure is wrong? How many people are more sure that the person who said you can't cover the one on the left is wrong? How come? Why are you more sure?
Sure. We've proved them wrong already.
How many people agree with that? What about the person that said you can cover? Has anybody covered the other one? Are we less sure that that person's wrong? Might somebody have a way to cover that? Maybe? Okay. Yeah, and keep in mind, I'm pulling no tricks. So that's a good idea. I like that. If they had another decorative tile, but we're pulling out tricks. How many people think that other person is probably wrong? Probably wrong.
Cool. All right. How many people think if we moved this decorative tile around, we might find some other locations that we also cannot cover? So I'd like you to do that at your tables, is to find some other locations that you don't think you can cover, cannot cover.
Something that you can't do that's similar to this one. Good. Would someone like to tell me some other location similar to the one up there that they cannot do? Dawn.
All of the odd squares. So if you start in the top left-hand corner and you go the next one over and you color that, you can't do that.
Raise your hand if you got something similar. Okay.
So skip the next one, do the next one, color that, can't do that.
Okay. Okay, I'm just curious. Did someone, how did you know that going all the way around the whole? Was there some conversations at the tables about, I can't see your name, sorry. Kathy.
It's just changing the position. If you take that square and you rotate it, you have to change the table.
How many of you heard the word rotate come up at your table? Okay, so this one? This one, yes? This? 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 Okay. How many people talked about why you can't do it? Have you spoke at your tables? So I'm curious, why don't those work? Why don't those work? And are there more that don't work? Yes. Shall I get those up? Yeah. Okay. Tara, could you help me out? Which?
It's basically a checkerboard. So, yeah.
This one?
The middle one, yeah.
This middle one?
I don't need that. I'm a
How about this
teacher.
one?
No, the middle one works. The middle one works. The left or right of that one don't work.
How many people know some others that don't work if the ones that Carrie's done so
And then the
far
one
don't
in the
work?
middle. Second row from the bottom. There you go.
Okay.
How many people agree that if one of those doesn't work, then the others don't work?
Okay. So why don't they work? That's the question. Yes. How about
Yeah,
if we?
I want to ask one more question. How many people are still more sure about the ones that do work than the ones that don't work? Right? The ones that do work, we know because we did it, right? But how many people, there might be some clever person who could do one of those so far. But I can ask, wait, how many people there might be a way? Maybe. Pretty sure there's not? How many people are still more sure of the ones you can do than the ones you cannot do? Oh, I like that. Thank you. Let me ask this question, too. How many people see a pretty pattern up there? How many think the pretty pattern makes you a little more convinced that you really can't do those? Okay, now here's what we're looking for, though. We want an argument that is just as solid as the argument at the beginning that said you could. Remember when we said, could you cover all 25? And somebody, the combination of people said, no, there's 25 and you can only cover an even number. How many people think we're short that quality of argument so far? See, talk in your groups and see if you can come up with an argument that's just as solid as that one for why you can't do these.
How many people think this is one of the harder questions we've done this morning so far? Why not? Right? Okay, so let me pause you there for a sec. So let me ask you a slightly different thing. How many people would like a little different task than you've had so far? A little nudge? Nobody wants a nudge? All right, how many people want a little different task, a little nudge? Okay, all right. So if you, and I want every person to try this on their own at your table and then compare some data, all right? So everybody's gonna do it on their own, so a little quiet individual time, and then when everybody, you're gonna share. So have yourself a new set of 5x5. Everybody at the table is gonna choose a place for that's a note that we currently think is not gonna work. The rest of it's gonna not be coverable. So everybody at the table is gonna agree on one of these blue locations that I'm modeling here if you're colorblind, one of these right-hand blue locations. So you and your table agree on that. So you got 5 seconds, agree on one of those locations. No, the whole table agrees on one location. You got 5 seconds. I'll give you 5 more since I clarified, and then I'm gonna bring you back out. Okay. Raise a quiet hand if you and your table all have the same location in mind. I got 1 table, 2, 3, 4, 5, 6, 7, 8. Are you guys agreed over here, Pat? 9. All right, so all 9 tables have one location identified. I want each person to, on their own, try and start covering with the 2x1s, and I want you to go as far as you can until you get stuck. Okay, go as far as you can until you get stuck, and then at that point, y'all can share and see if you notice something. How many people would like me to repeat those directions? I think I'm good. To share their data about what happened when you got stuck at your tables. You had a chance to share that? All right, so let me just do one up here. Let's act it out over here. I can pick any one of those, right? How many people agree I can pick any one of those? All right, so I'll pick that one. Oh, eraser foul. That's my decorative tile that's circled, and I'm gonna go about the business of doing what you guys just did. Did anybody already choose that one? Did any group? Yay, if I'd have planned that, that would have been good, but I didn't. Better to be lucky than good any day. So now none of you did that, so I'll get some more data, right? Okay, so I'm gonna go about the business of starting to cover this. And then watch and see if what happens to me happened to you. Yeah? More data? Okay. How many people think this is not going to be coverable if I keep on going down this path? Okay, I want to make sure I got that chosen right. This is okay to do like that? Yeah. Okay. Don't let me make an error. Am I okay so far? If I make an error, I'd like you to use a little silent intellectual protest signal. Have we done this before? I don't think we have. I have to put the mic down to demonstrate. Don't hurt your neighbor when you do that. So that's the signal you can do. If you have a difference of opinion, you can do a little silent intellectual protest when I screw this up. All right. Is that good? How about like that? Just checking. Okay. How many people agree I got stuck? All right. Huh. How many people had something similar to them happen? Did anybody have a statement about that they heard at their tables about what happened with when you guys got stuck, and maybe even also what happened when I got stuck? What's going on there at the end? Anybody got something they noticed about what's going on at the end? I got one person, 2 people, 3, 4, 5, 6, 7, 8. Ooh, this is good. All right, let's see. I have choices. What do we call him? I'm going to call him that gentleman whose name I can see begins with it. Tony.
Well, we were talking about that wherever you place it on the checkerboard, and if you have the even number 2 by 1, it's impossible because you're always going to have an odd number 3 on either direction. So that's why we said you can't, because you can't take a even tile and put it over odd.
So when you're saying the even tile, you're talking about the fact that this thing that I'm putting on here
Yes,
covers
the
2
2
squares
by
being
1,
even?
yeah.
How many people understand what he means by even? All right, so I'm trying.
You'll always have a odd number on one of the directions, the 3.
So are you talking
Like
about
to the
odd,
right.
like right here I have 3 squares to the right of my square that I'm trying to place it?
Yes.
How many people were trying to check out the neighborhood and whether that stuff was even or odd around the square that was placed? Okay, yeah? How many people think that might have something to do with it? Cool. Were there other things that you noticed about these 2 squares that when you got stuck? Those were the 2 squares after I got stuck that I couldn't cover, right? Did anybody notice anything about those 2 squares? Oh, cool, I got 3, 4, 5 hands up. Stacy. You're Stacy, right? Did I screw that up? Okay. That's one of those where I called on you and I didn't look at you, so that was a foul on my part. Sorry, Stacy, I'm looking at you now.
So we noticed at our table that every person that, when they got stuck, the tiles that were left open were the non-colored in checker tile. Does that make sense?
How many people think they might want to check that out on their papers for a second to see if they could check on the even or oddness that Tony said, or the what color are the tiles? Because I can't tell because I erased all mine, right? So check out those 2 conjectures at your tables about that they're the same color or the odd number of squares somewhere in the neighborhood, and then we'll come back together in a sec. Check those 2 things out, see if that works for you. Tony gave us one thing to check out, and Stacy gave us another thing to check out. So how many people noticed that there was some even or an oddness going on in the different neighborhoods of these tiles that we think were the decorative tile? How many people noticed that going on? So that was not everybody, but that, okay. So it's interesting, so I'm not quite sure about what to do with that information. And then how many people noticed that these 2 were either both tiles that were previously yeses, so maybe they were uncolored, or both tiles that were previously no, and so they were colored? How many people noticed that? That's a little bit more people. So I guess I want to have you think about this too. If I'm going to place one tile up there somewhere on the checkerboard, what for sure has to happen? So think about that in your mind for a second before we take hands. If I'm going to place one tile somewhere on that system up there, what for sure has to happen? So how many people have an idea of something they know for sure is going to happen when I place just one? Just one.
What for sure does it have to cover?
Oh, how many people think that's a more specific question? What for sure does it have to cover? All right, so what for sure does it have to cover if I place one tile up there? Anita, you got an idea? Okay. Here.
Ooh, I get to use the blue one?
Sure.
Well, you always have to know what your purpose is. So if I want to teach my students that it's going to evenly cover it, then I need to know that for sure. Or if I don't want it to evenly cover it, if I want it to cover it, then I definitely have to go with one of the blank areas that we identified before. But if I don't want it to cover it and I want them to sit there and be bewildered as typical, then I want it to be one of those, you know, evens that we all identified initially at the beginning, the every other one. And I know Allison has a really great item to share from 3rd grade.
Well, hold on, I didn't see her hand up, so I'm not going to call on her. But let me ask a different question. So how many people think Anita was talking about the placement of this decorative tile and stating that very well about whether those things would result in a coverable remaining portion or not? Okay, so I'm going to ask a slightly different question. I think my buddy Rick is going to help me draw a picture. I think. Oh, nope, he's doing something different. So I'm asking if I place one of the 2x1 tiles up there. So say we already picked the location that anywhere that Anita said. Doesn't even matter whether you pick your decorative tile to be in a place where it's coverable or not coverable. I don't even care. But now I'm gonna, nothing's on the board yet, and now I want to figure out what for sure is gonna get covered if I just place one 2x1 tile on the checkerboard. That's what I'm looking for. What for sure is gonna happen if we place one 2x1? How many people think it's gonna cover an area of 2? How many people? That's one thing that's for sure. Anything else that's for sure gonna happen?
I just want to, how many people have a picture somewhere in their group of like all of the squares that you can't cover? I mean, if the decorative tile was there that you can't. So yeah, it's something like that. Yeah, can you hold that up? How many people have something like that somewhere? So if you look at that, regardless of where you put the decorative tile, if you slap one 2x1 tile down, what does it have to cover? How many people have an idea what it has to cover? Talk about that in your group for just a second. So how many people know what that thing has to cover? No matter where you put it. Who can tell? I heard it a bunch of places. Who can tell me something it has to cover? Way over there from Carla? Yes.
Cover 2 squares that are side by side. They can't be at a diagonal.
How many people agree with that? And what do you notice about any of the 2 squares that are side by side? What do you notice? Scotia.
One will work and one won't work.
How many people agree with that? Scotia, just that. All right, okay. I could have asked agree before I even called on, when I called on Scotia. So let me check with that. How many people agree that it has to cover 2 adjacent squares that share an edge? And how many people, if you piece that together, it has to cover one of those, one of the yeses and one of the nos, if you will? All right. And wait a minute. When Deb asked you a while ago to put them down until you got stuck, what was always left uncovered? 2 of the same, 2 of the good ones? So I want you to talk about that in your groups. If you can take those things together, you know what one domino covers. Why is it that you had to get stuck with 2 yeses at the end? Should I repeat that? If you know one domino covers a yes and a no, why is it that when you're done you have to have 2 yeses left? How many people think we're probably getting close? Getting close. Here's, I heard this some places, but I want to make sure we chunk this out in little pieces. Can somebody tell me, so let's see, if we agree that this is the one we're going to put the decorative tile on to begin with, how many squares are there left? And how many people think that's good, that's an even number? Can somebody tell me, if we'll just agree on that one for now, it's the same thing true with all the others. But if we do this, can somebody tell me a significant thing they noticed about what's left? Take a hand for that. A significant thing that you notice about what is left. How about Karen?
Well, I was looking at the pattern of the checkerboard with the white and the black, and I noticed that there were more white squares than black squares. So if I cover...
I'm going to cut you off right there. Thank you very much. How many people believe that if we... I'm be nicer if I had better pictures up here, but with this one, so let's say, for example, if I took this out, How many people counted the white squares and the black squares or blue or whatever they are?
How many people noticed I don't have all the blue squares up there? Okay.
Well, they're not all up there? So let's see. How
No, I don't want
many
to. I
of, somebody's already done it and the picture's not right. How many of the white squares are there? Anybody just hollered out? How many people agree with 13? And if there are 13 of the white squares, how many of the blue squares? Because I've only got 24. So if there's 13 white ones, there's how many blues? How many people agree there's 13 of one, 11 of the other? I want you to think about that in your groups for a second. And if there are I'll even write this on the board. If there are 13 of the white ones and there are 11 of the blue ones, what's always left when we get stuck? Two whats? Talk in your groups for a second. Why are there always two whites left? I'll give you about 18 seconds for that. Let me see how many people agree, since we're starting here, how many people agree that when you're done, you're always going to be left with two blues? I thought we agreed on that. 3 whites. 2 whites. How many people agree 2 whites? Because if I start this way, when I put one tile down, what does it cover, everybody? One of each. So when I put one tile down, what's left? I know this is higher math. How many of these? How many of these? And then when I put the next one down? How many people were heading to a place where we're going to get stuck? There's always going to be what left? Well, you know what? Maybe there's a case where the 2 whites are right next to each other. Just put the domino down and cover it. You guys don't like that one, huh? How many people agree the 2 white squares are never sharing that edge that Carla was talking about they needed? How many people think we have a pretty solid argument for why you could never cover taking one of those out? Always get stuck. I
don't think we have to look for 1,000 years anymore.
That was a challenge, huh? Yeah, you're allowed to clap. That's okay. All right, nice work.
I'm going to leave you in your same seats for now because you just did some math with these same people and it may help this discussion. So now we are changing your hats. For this morning, you had your learner hats on, experiencing stuff from the learner's perspective. And now I want you to flip your hat and you can put your teacher hat on. That doesn't mean you have to totally forget about your learner self, all right? But now we're going to go back through some of the things that happened this morning with our teacher hats on. Okay, how many people are okay with this? Good, thanks. I probably would have done it anyway if you didn't raise your hands anyhow. So, I bet you guys noticed this. How many people noticed that we cared about the quality of the reasoning today? So I want you to kind of think back to how we established our standard of reasoning that we were going to go about doing this morning. And we did it fairly early on. How many people can think of us talking about a solid line of reasoning early on in the day? You remember us talking about that? Does anybody remember what kind of the first time when we established how we knew something for sure? Anybody remember what the question was on the floor when we realized we knew something for sure could or couldn't happen? Anybody got that they think? How many people remember that we started talking about 25 squares for the day?
I thought you had 25 hands up. So.
Oh, how perfect that would be. So before we started coloring any of these squares, how many people remember we just had the blank when, and Rick was making jokes about his artistic self? Anybody remember that? We had the lightly drawn, right? No squares were shaded in at this point, so this one wasn't even shaded. How many people recall that? Anybody remember how we decided that we could not cover that with a whole bunch of 1x2 bricks? How many people remember that?
And this is before the decorative tile got introduced.
Did we have to search for a long time about why we couldn't cover that with 1x2 bricks? So how many people think that was our very first time of establishing our mathematical solid line of reasoning that was going to tell us why we couldn't, in this case, could not do something? All right, so we wanted to make sure and call attention to that so we would be able to use that moment. And how many people recall us asking you to think about that moment later a couple times throughout the lesson? Okay, so that's kind of what I want you to, at your tables, unless somebody wants to add something to this, I want you to think about what other places were you kind of nudged to or pushed to come up with some reasoning? What other prompts did we do maybe with somebody in your group even? So what other places were you nudged or prompted to stretch your reasoning and kind of get a solid line of reasoning? Think about a couple of other places. It could be after that one. So we have that one. Yeah, so the whole morning, right? So after that, so think about a couple spots where you were, what was the prompt? What pushed you? So how many people at their tables talked about at least one other place where you were nudged to develop some more lines of reasoning about how you knew something? Anybody willing to share one of those? Well, that's interesting. Okay, so that's, oh, thank you. So I just had to do a little wait time.
We just said that when you asked us to, like, how sure are you of this one? Are you more sure that it's not possible or more sure that it is possible?
How many people talked about that spot as a particular spot? How many people agree that is a place where you were really thinking about what entitled you to be more sure whether you can do it or can't do it? Okay. Any other spots that people were thinking about? This is hard for me to do space well because I have to come right over to the, and really when I don't have a microphone, I would want to be standing in a totally different place than this. How many people can imagine this? All right, here you go, Deanna. Deanna.
The piece of information that was provided where a tile had to cover one of the colored spots and one of the non-colored spots was a big hint.
How many people agree with that? Anybody got any more? Rick and I have been working together a while. He knew that was okay. Of course, he doesn't know my bifocals have made it harder for me to do that, but another spot.
Well, what I was looking at is once you kept saying the number 25, 25, and then I thought, well, because that's an odd number, what if we went 36, which is an even number? Can we just only, because what I did is I numbered them by rows, and I numbered them from top to bottom, 1, 2, 3, 4, 5, 6, 7, all the way down, and every odd number was colored, and you couldn't. And then I went to, what if you went 36 by 36, which is even, and then you went to 100?
How many people think that she asked herself her very own question to push her reasoning? Because she was going to 6 by 6, and she had an old numbering scheme. How many people think that's a good thing? Okay. Any other, one more spot we haven't said? Anybody didn't get a chance to share about reasoning? I'm in the mush pot, man. I got to get out of here.
I heard somebody say something, and as it's kind of walking around, your people were talking, when I think Carrie asked, if we knew we couldn't do this one, how many people knew some others right away that they couldn't do? How many people remember that question? How many people think there's some nice reasoning when you guys talked about rotating and flipping and all that stuff? Okay, so that's lots of little places.
Oh, and that prompted Ellen to have another thought.
Well, we drew a picture, and once, like you said, we started looking for patterns, and there was a clear pattern. And once we got started, it was very clear what worked and what didn't, and it kind of brought it all together for us.
How many people think that place where Carrie put one square up and then asked if you thought of some others, coupled with helped others have that aha that Ellen had, that the pattern was actually helping us get some more, because we could start thinking, coupled with that rotation on the reasoning. All right. Cool. So that reasoning, how many people think that's one of the standards for mathematical practice? Right? So we were working on constructing a viable argument today. We didn't actually say, thou shalt go forth and construct a viable argument. So this is the thing that we need to think about how do we do this for the kids.
It's on the board outside the hotel.
Oh. There we go. It's nice of the hotel to put that up for us.
Yeah. I had them do it.
You guys are not going to believe anything he says ever again, are you? Okay, so let's see here. I got a different thing to think about. So I got to read my own handwriting here. That's hard. You might have also noticed that we asked you some pretty big why questions today. How many people think there was more than one time when we asked you why something was true or not true? And we asked those big questions. And then how many people noticed that after we asked those big questions, we might have gone to
How many people notice some questions we asked you that we let you struggle for a little while?
How many people think that's kind of important? Okay. You guys didn't fall on the floor and cry, did you? While you struggled? Nice perseverance. Oh.
We were watching.
That's true, we were watching. So, it's because the camera was rolling. You didn't want to be crying on camera, huh? All right, so then after that, after we'd asked the big questions, how many people noticed that we might have gone back and asked some more scaffolded questions to have you make some progress? Anybody remember some, towards the end? I'm looking up here. Remember we were wrestling with how come we had 2 yeses left? How many people remember that? I wonder if you could talk at your tables and identify what were some scaffolded questions, because we worked on why were there 2 yeses left for a while. So maybe talk at your tables about what some questions after that larger why question, what were some questions we asked to sort of help your thinking along? What were some scaffolding questions that might have helped? So just, maybe this might be a 1-minuter. Do you want to add something here before we send them?
If we go back to, I think the big question was to come up with a reasoning why the ones we thought you couldn't do. How many people do that? That was the big question. The ones you can't do, why is that true? So if you think back, if you want to go back and talk to the camera people, maybe they'd let you run the tape back. But if you can run your personal tape back, what were some little questions we asked you after we let you struggle with that big question? What were some little questions? It may be easier for you to think about what were some observations that were made that helped us get to that idea that there were 13 and 11 and blah, blah, blah. If you can think about what those observations and what questions. Okay, so talk about that for a minute in your tables. What were some of those observations that helped us get to that final reasoning? So how many people found at least one other place where there was some observation? What's one observation that you made that helped us get to the big thing? Thank you, Robin.
Well, when you had us as a group choose one square and then work our way around that, and then asked us to notice the 2 remaining squares that were left over. What did we notice as a group about that? I think that was a moment where some of us had light bulbs that went off.
How many people think that turned out to be a big deal? Okay. I don't remember who did that, but when that was done, there was a way of doing that made a lot of data collected in a hurry. Does anybody remember what that was? I wasn't in the room, so I'm just assuming.
I remember, because I pitched the question.
Did you guys do that as a group or do it individually? Do you remember when you put squares down till you got stuck? Individually? So how many people, by doing that individually, all of a sudden you had, for example, this table, I can't count this fast, 9 or 10 pieces of data instead of just one. So that observation kind of jumps out at people. So that was a nice way they did that. Any other little things? How many people? I remember one thing. I think it was Carla mentioned about the adjacent. That the 2 squares were adjacent. How many people think that turned out to help you at the end?
That they weren't adjacent?
Oh, that when you put a domino down,
gotcha.
When you put a tile down, it covered 2 adjacent squares. They had to share a boundary. Any others? Okay. So there's a little bit something that we want to kind of call out here. There's a little bit of weirdness here in that we asked that big question, let you struggle. That's true, huh? And then we came back and put scaffolding on. How many people think that's backwards from the way it's done a lot of times? Is that true? Let me see. Oh, how many people think that's at least backwards for a lot of common teaching practice that you scaffold your way to the. So I want to just talk about that for a second because this is something I know at least me personally I've been thinking about this a lot the last couple of years. So the first piece of this is that if you ask the big question and the kids don't get it, can you put the scaffolding on? If you don't ask the big question and put the scaffolding on first and lead them to the big question, can you then at the end take the scaffolding away? right? You know what I mean? It's there. So that was the first thing I started thinking about, that I can always, when I need to, I can always go back and put the scaffolding on. Then I started thinking about this from a slightly different perspective. If we accept that what I'm trying to do in my class, kind of an overriding goal, if you will, is to get kids, I'm a mathematician, so I like to say one of my primary goal in my class, overriding generic, I'm trying to get kids to think like a mathematician, okay? Now, if you put it in more common terms to be a problem solver, think about the two scenarios. You ask the big problem, and the kids get stuck, and you apply the scaffolding. Or you don't even tell them what the problem is, and you scaffold your way to the answer. Which one's going to create a culture where the kids become good problem solvers? How many people think the first one? Okay, so this is a big deal to me if you think about it. That, see, I think the culture I'm creating, if I ask the big question first and let kids struggle a little bit, and then I go back and I put scaffolding questions, then what's that? Well, not everybody, but what's my goal? I'll get you 1 second. What's my goal then for what happens to that kid next time they get a question that they have a tough time answering? What do I hope they do? How many people, I'm hoping they look for the scaffolding question, okay? I want kids that I work with, college or elementary school, it doesn't matter, that when they get stuck on something, that the culture in the class is that they say, there must be something I know or an observation I could make that would help me get from where I am to here. Instead of saying, I'll wait till the teacher tells me the answer. Okay? So I see a couple hands up.
How many people agree that would be a good culture to build in our classrooms? Yeah, and we started thinking about that. You had a couple hands.
You know, this is a huge mind shift for educators, because we are trained, and as administrators, we go in and we observe teachers, and we encourage them to anticipate what problems kids are going to run into and be prepared for those first, rather than giving them an opportunity to grapple with the big problem and then scaffold them later. And so I think that's a really big mind shift for educators, and it's going to take a lot to get some folks to turn that around, but it will be great when we can.
I want to add something to that. So she said something I think that is really, really, really important to me. You need to be aware of where those places are going to be. That's still as or at least or more important than it ever was. The only difference, again, she said this well, I'm just not putting those there first. What we did is we walked around. You guys notice walking around when you guys were working? We're listening. If somebody came up with one of those things and we didn't need to ask the question, this is great. Independent learners, I like that. But if you get stuck and we start to see that the perseverance is, starting to drop a little bit, then we drop in one of those scaffolding questions. So you still need to know that stuff. Somebody had a hand up over there too. Nice.
Bill did.
Bill, I'll just have to ask this question before. Are you going to sing this or just...
That's an old story. I did the Math Institute with these guys like in 1998, and they made us do a culminating activity. So I put mine to it was American Pie, I think.
And it was awesome.
It was
we might be able to pull out the video.
Thank you for remembering. Well, the point I was going to make is that for your math, one of the ideas a lot of kids don't get is there's an explanation for everything. It's not just some sort of random thing. For example, with this problem here, as far as the perseverance is concerned, I can't prove it yet, but I think there's an equation for for why.
Let everybody see what's going on.
See, I've been goofing around. But there's a reason for why answers are correct, and a lot of times, kids get to that place and they, it was like some sort of magic that happened. That got him the answer. But no, there's a logical reason for why something is right. That's a lot of times the part that's missing.
That, by the way, also is a huge piece of the culture I want to create in the classroom. And I'll say this now, this would be a speech that would come up later, but this whole Common Core thing, we've done a fair amount of professional development. And don't feel like that any of us are saying that you have to know the reasons for everything you teach. Okay, that's no way that's going to happen. I know reasons for stuff now that I didn't know a couple of years ago, and I've been doing this for 20 plus years. All right. So this is going to be an ongoing thing. But when you have, you know, your PLCs and stuff like that, and you find out, you know, some teachers find out a reason and a way to teach something for reasoning, then they can share it with somebody else. This is a plus. But this is going to be a years-long thing. Okay. But the culture is that I would like people in this room, and I'd like to sort of imbue in students, is that there is a reason. I might not know it, but there is a reason. So math isn't something that you all just have to memorize a bunch of facts. So if there is a reason, and they're curious to find it. But don't feel like anybody here is sending the message that when you walk out of this, you know, like when you start, you know, I guess you guys have already started school, but you're supposed to all of a sudden know all the reasons. Not going to happen.
It's not instantaneous. Okay. Well then, I think I'll go to my next spot. How many people think, Bill also asked himself a next question, and his group mates? Yeah, so we had two people share some things where they already asked themselves next questions. Very cool. So I want to talk about a slightly different thing. So that's kind of on the content side, where we're really thinking about math tasks that we put before students and thinking about asking them the big question first and being ready to come in with those scaffolding questions should they need them. On the pedagogy side, to try and create an atmosphere, there were some things that were being done early on. So I want to bring us back way to the beginning of the problem. Before we even put a decorative tile up there, Rick said, asked everybody, if we started just putting a 2x1, put a sequence of 2x1 tiles on here, and he asked everybody at once together to say how many tiles, how many squares would get covered if we covered as many as we could do. And you guys all chorally responded 24. How many people remember this? And then he switched and he said, show me on your fingers how many squares would remain uncovered. Does anybody remember what you showed on fingers? So how many people recognize those are two different modes of response used for the learners right there? The first one being choral, and the second one being what? Visually, he saw what? Yeah, signal. He showed you. He saw you guys, right? Holding up ones. Digital. That is nice. Nice. Nice one, Michelle. Oh, nice one, Tara. So those are two modes of response. How many people think Rick was getting some feedback about your understanding of the problem at that point so far? So that was a purpose for those particular modes of response, but I want to have you think about for a moment, see if you can come up with some other modes of response that were used in this morning's lesson besides everybody together say something or show on fingers. How many people have at least one other mode of response in their minds right now? How many people think we're doing it right now? Okay, so that's one. So talk at your tables. I'm not going to give you long, maybe 30, 40 seconds, and we might call you back to some other moments. What other did you see this morning? Okay, this morning in here. What else did we do? Go. All right, so how many people thought of at least one other mode of response that was used this morning? Okay. Anybody willing to share? We could just go kind of rapid fire. I'll just go all oh, I don't want to leave you guys out. My bad. I'm looking. Who wants to share one? Yes?
We use our whiteboards.
How many people agree with that? Okay.
What I noticed was that there was a variety of different options for us to pick from. So we could choose like the graph paper or the white paper.
So how many people agree you even had modes of response within your table group that you could choose from? Okay. Any other modes of response out of table groups? So you had all those, you had whiteboards at tables, graph paper, plain white paper. What other modes of response publicly did we do? Is there a hand over here?
You called out individuals.
Like I just did to you and I didn't use your name. Liz.
And then show of hands.
How many people agree we were calling on folks that volunteered by name to answer questions? And how many people agree we were having you vote by show of hands? Okay, there, we just did it again. But that's like, I don't know, repetitious when I do that, right? Okay, any other modes of response? Oh, she had a thought.
Think, pair, share.
How many people agree you were sharing at your tables? And sometimes your tables turned into pairs, right? Okay. I see someone doing this. And we introduced the new hand signal, right? I'm having a hard time doing it with the mic, right? Yeah. So there was a silent intellectual protest, okay? Anything else that you noticed? So here's something to think about. Of all those sorts of modes of response that we just used today, how many folks can think that some of those are a little bit less risky for participants to use than others? from your perspective? How many people think that could affect engagement? So from an involvement perspective or an engagement perspective, that's something that we're considering. How many people think show on fingers is fairly safe? How many people think just voting is even safer than show on fingers? All right?
What can that kid do that's unsure of him or herself and they've just asked on your fingers? Right? I mean, you'll see kids go, this is when it's not an advantage to sit in the front of the room. Yeah, I mean, if you look at it, people are talking over here, they know which kid to look at. How many people think the kid that's unsure of themselves look over there and say, hey, man, Tom's got two, hey, you know. One of the things I hear a lot from teachers, what about copying? That an issue or not? Is it bad? Is it bad if you have a kid who doesn't have a clue but wants to put their hand up and show the answer and copies? I mean, okay. I mean, it's a start, right? There's somebody say it's a start. That person wants to participate. This is a good thing. What can you do? Maybe there's an example of something you use on your fingers. What about the kid who hasn't participated much and doesn't have their hands up? What could you do? We didn't do it in here.
No, we didn't have to.
We didn't demonstrate this. One of the things that's really nice, or the kid that always, you can do this with when their hands are up as well, have a kid who's not participating call on somebody with their hand up. Okay, there's a tremendous, again, for me, I talk a lot about culture, but there's a huge culture change in the class when, somebody back there is not paying attention. So what you do is, hey, what do you think the answer is? You make a fool out of them. That's always gotten more people to participate. That kid that you did that to, oh man, I'm going to pay attention now. But you take that same kid who isn't paying attention, they're talking, and say, hey, what do you see on their fingers? Calling somebody with a quiet hand up. Now, it's a complete different shift in and one of the things I believe, so you can assume it's true.
Sorry.
Is I think subconsciously when you treat kids that way, that they recognize the difference, and you get that back. I don't think any kid I've ever had in a class could verbalize that, but I think there's an atmosphere in the class. So, great place to use fingers. Just, hey, what do you see the most of?
And you can think about the kid if, say it was Fran, it's not Fran. Say I just said, hey, Fran, what's the answer? Versus I said, and think about this from Fran's perspective. Fran, would you call on somebody with a quiet hand up? In which place is she feeling more powerful? Does she get the message either way that I kind of noticed? And so it's a little bit more respectful, and so she might be more likely to quit being mad at me and just get back into it. Yeah, so these are kind of things that you want to kind of think about. There's the little tiny things that are going to help. Carrie.
One of the other places that I noticed when Deb said, on your own board or on your own paper, your own thoughts, when she had talked about the why the one particular one doesn't work, choose one at your table and then on your own, write it at your own table by yourself. So she gave you permission to think on your own. And then she said, think in your mind on your own. How many of you think that's a good place for kids to be also?
Yeah. How many people think that's a safe place for kids to be for a minute while they're thinking on their own?
How many of you enjoyed that moment? Yeah.
Wait a minute. When you guys were doing that, you were totally quiet.
There was no sound.
Yeah, you were busy trying to figure out where you were going to get stuck. Yeah.
Yeah.
Cool. So that's another motor response we hadn't yet identified. Okay, so one other thing to think about. So we thought about motor response from the involvement and the engagement side from learner's perspective. Well, now I'm going to have you put your teacher hat on. Those different modes of response, how many people think it gives different information and feedback to whoever's doing the instructing about what people are thinking? How many people think different modes of response are good for different things there? So that's something else to consider. Is it time in the lesson where I need to do a check for every person? So do I want to see on whiteboards? Is it time in the lesson where it's okay and everybody can be looking around and seeing why everybody's holding up ones, right? I need to balance this and think about when's a good time for, am I going to get feedback as a teacher? Which mode of response is going to tell me what I need to know in order to figure out what my next step is? And this goes along with last year when we were playing kid detective, right? This is the kind of stuff that you can craft when you're trying to, in the middle of the whole class discussion, get some feedback from students to know where to go next as you're busy playing kid detective.
Much as we can live time, just like we would do with kids. And so we always preface this with, so you get to raise your hand and answer, kid answers, but this doesn't mean act like kids. All right, so thank you. All right, so let's see. So you have never seen fractions before. How many people can live with that? How many people wish they could live with that for a long time? All right, okay, never seen fractions before. So let's see. Can you guys in the back, is this gonna work? Can you see this? Okay. So if I take that line segment, I tried to make those, how many people can imagine those pieces being equal size? Show me on your fingers how many sections I cut that line segment into. How many people? We work together. How many people agree with 5? Okay, let's count them just to be safe here. Everybody? How many people agree there's 5 segments up there? Okay, so if I did this, everybody, how many of those segments did I shade? Everybody? 4. Nice, nice, nice. So let's see, I'm going to draw another one. This time it's supposed to be the same length roughly. Everybody, how many segments did I cut the line segment into? 4. How many people agree the denominator is 4? And if I do this, how many did I shade? Everybody, 2? Okay. Well, we'll keep going a little bit, I guess. So let's see, I'll do the shading right now. So let's see. How many people know how to hold your hand up if you know how many segments I cut that into? Show me on your fingers the denominator. How many people agree with that? And how many people, raise your hand if you know how many I shaded. So everybody together, what's the numerator? 2. How many people, everybody look at Deb. Now you're not being students anymore. This is something we'll do throughout the day. We call this a teacher timeout. So now we're not students. Deb has a teacher observation to make.
How many people notice the use of the word denominator and numerator in that? So I want you to think about, if you had never seen fractions before, how many people think you already have an idea about what the denominator is telling you? So I'm curious, when was the first time he used denominators? Anybody remember when the first time he used denominator? Oh, is it Lori?
The second.
How many people agree in the second demonstration? Does anybody remember how he actually, he didn't do this. Okay, open up to the glossary. Let's look up the word denominator. How many people agree he didn't go to the dictionary or the glossary? He kind of did it more, just did it, yeah? All right, does anybody remember what question? I should have been writing it down. Anybody remember kind of what question he asked about? They got a shot, maybe? Vanessa?
He asked how many segments, and then he went to the fraction line and said, so what number goes in the denominator?
How many people recall something like that? How many people think he just defined what denominator is doing without defining what denominator is doing? Counting the number of segments in the whole? Okay.
So one thing, when I asked that, if you were kids, now, and again, if you'd never seen fractions before, did you already know the answer to my next question before I even used the word denominator? Okay, because I already asked how many, and pointing down there, so you kind of already knew. Okay, go ahead.
How many people think he was consistent about which one he was asking for first throughout all 3 examples, which helped with what he was just saying? Okay. And then, Gary, you got a thought about, you can help us out because you were actually writing stuff down, huh? Cool. It's nice you guys to wait while we pause.
On the next one, he said, how many people agree the denominator is 4? So that was the next step. So he introduced it, and then he said, how many people agree the denominator is 4? And so he got everybody's response on that.
How many people think he did that on this one too, for denominator? So what did he do on, is there a way he did numerator that applied what he said a minute ago as far as you already knew the answer to the next question? How many people think he did something like that when he got numerator introduced? Anybody remember how that went? It's handy to have Carrie taking notes. Oh, I got people over here. Dawn remembers.
How many did I shade? Oh. He started out with how many did I shade up at the top, and for the first one, and then for the second one, he said how many did I shade, and then he said what's the numerator, and we did that, and then the second one, I think he went straight to what's the numerator.
How many people think there was a progression by the time he got to the third one? I'm thinking he might not have used it. I can't remember if he used the word numerator on the second one or not. I'm thinking he might have said it here like she said it here where we knew how many were shaded, and then he said, so everybody, how many people agree that 2 is the numerator or something like that? Right, so there's ways to sneak in vocabulary besides going to the glossary of the dictionary where you can use it in context. You gonna tell your story? Or you have a next thing?
I don't know what story.
That's not surprising to me.
I do have this. So right now, well, first of all, how many people, like this is a cultural shift in the way we teach, right? I mean, vocabulary comes first. If you think about this, if in your head for what you'd like for your kids, would you rather, when you're introducing this stuff, now I'm not saying vocabulary is not important, we'll come back to that in a second, but would you rather have your kids know the role of the number on the bottom, or would you rather have them know what it's called? Okay, now, that was the right answer. Now, please, that does not in any way say that we do not want a day or two from now the kids to have denominator in their vocabulary and have it memorized. But initially, the role is more important than the word. Okay, that's my opinion. Okay, and so when you get at this stuff, I mean, one of the things. Maybe this is the story, I don't know. One of the things I'm listening for vocabulary is I want to hear the kids start to use it. Okay, so the first time, and this usually happens when I've taught this stuff to little kids and I've written a curriculum and we've had a ton of teachers use the curriculum. Deb's taught it a bunch. I mean, and so we kind of, in a sense, collected a lot of data on this. But within a day or two, the kids are using the vocabulary. Now, I know this, if I'm working with a second grade, third grade, and some kid says the denominator is 3, then I'm going to say, how many people heard a word in that explanation that I really liked? And the kids raise their hand. I say, everybody, what was it? They say denominator. Now, what's every kid trying to do in that room? Okay? That you want to get kids to use vocabulary. Single it out when they do like that. Ask the other kids what word would you, and you're going to get more and more kids using them. So,
cool. So we can unteach your timeout. That was a long one.
Okay, back to live time. Though this is going to be tough. So I don't know how many examples it takes. It obviously varies kid to kid, but how many people can see in 3, 4, 5, somewhere less than 100 examples kids would have figured out? You can draw a picture and they know what fraction it is. We're good with that? Okay. So back and forth. We mentioned motor response. At some point, when I have an inkling that the kids know, I'll draw a picture up to the board. Say, write the fraction on your paper. I'm sorry, I'm not 100% here today. Write the fraction on your paper. I will tell you that one time I did this with kids, and I knew they knew the answer, and I went around, and they all had the wrong answer on their paper, or lots of them. And I thought, what is the deal? But then I looked, they drew the picture too. And they drew the picture wrong. Okay, they didn't copy the picture. Maybe the picture on the board was 4/5 and they did 5/6, but they all had the picture and their fraction matched.
Just didn't match yours on the board.
Just didn't match the one on the board. So they, this was good. Okay, so we've got the kids. They know this. This is going to be tough.
So are you going to go back and do some stuff on whole number lines first?
Not yet.
Okay.
But I will. I want to get fractions on the number line first. Okay, so the kids are good at that. I draw something that looks like this, and I go, so let's see, everybody, what denominator am I talking about? If I shade this much, Everybody, what fraction is that? And if I shade this much, what fraction is that? And this much? And this much? How about this much? And this much? How many people agree with that? So let's see. Show me on your fingers 5. This would be what equivalent to what whole number? How many people agree with 1? Now sometimes when I ask that question with the kids, I don't get it and I don't care. Okay, then I just say, how many people agree it's 1? This is not the hill I want to die on. All right? But once I get that, everybody together, what whole number is this? Okay, if I give them this, I never have trouble getting this. So how many people think this is starting to look a little bit like a number line? So if I do this, if I try and be careful here, trying to make these spaces the same. This would be I'd be saying this if I was with kids. So let's see, if I made those spaces equal, everybody, what whole number goes here? 2. And what whole number goes here? 3. All right, and I got to do this because it's so much fun. How many people think I could just keep chopping this thing up into fifths? How many people think together we could count our way all the way out there? But I want you to do this in a special way. Whenever you say the fraction under a whole number, I want you to shout it out loud. But if it's a fraction that's not under a whole number, I want you to whisper it. We should practice, huh? All right, so everybody, this one? This one?
0.
That wasn't, come on, let's try that. This one?
0.
That was pretty good. Okay, so here we go, all the way out to 3.
0. 5. 10.
The suspense.
15.
Okay, teacher timeout. Now, go ahead, well, and I'll see if it's a...
How many people think, besides fun, there was probably an instructional purpose to that whole whisper and yell thing? How many people have ideas about possible instructional purposes for that? So talk at your tables. I didn't see very many hands, so I'm going to react to that. Talk at your tables. You only got a minute. Possible instructional purposes. Why would we want you to whisper and yell on those things in the way we asked you to do that?
Tony, you ready?
I think they figured out why whisper and yell.
How many people think we'll use a terminology later called MIF? Anybody heard of MIF techniques in here? Okay, well this will come.
What did you say?
MIF, M-I-F-F. This will come up later. One of the F's. Remember Deb was talking about feedback from students on motor response earlier. One of the feedback. Getting feedback is one of the things. The other F stands for focus. How many people think that there was some nice focusing going on in that shouting and whispering stuff? What was I trying to get you as students to focus on? Tony. Knows that quiet hand, I like that.
To figure out which fraction is equivalent to which whole number.
How many people think that shouting thing? Could you guys, I could hear it. Could you guys hear that back here? How many people think that whisper shouting thing started to really focus kids on what fractions equivalent to a whole number and stuff? Okay, nice.
Unteacher timeout.
Unteacher timeout. Okay. So we had a little caucus here, which direction we're going. But so I actually literally had this happen when I was doing this in an experiment in a 3rd grade class, and that similar deal like this, but this is something I decided is good mathematically. So now on teacher timeout. So I had this number line, and then I was going along, and something weird happened. But down here is 8. Does anybody have a guess? Think about put yourself in whatever grade you think this is appropriate to teach. What would kids guess how many fifths that 8 would be? What fraction would go down there? Anybody have what might a kid say? How many people? They might say 40. Anything else they might say? They might say 8, okay? How many people you might be surprised by something at least one kid would say?
I heard someone say they might say 16.
Might say 16. Might say 30. There's all kinds of stuff they might say. All right. So
Might say 20.
let's see. What I want to get at here is this. So if I talked about, well, let's see. I guess I'll do this. So let's say we've had this discussion. Let's make this live time again. Well, this is teacher timeout. What are some ways, if a kid got 40, what are some ways the kid might have gotten 40? And by the way, how many people can think of more than one way? How many people think some are more sophisticated than others? One way, anyway, I'll take a hand, one way. Vanessa?
Count by 5.
How many people think they might count by 5s? Anything else? Anything else they might do? Kathy?
Multiply.
How many people think they might multiply? 2 times 20. Isn't that 40? That's the wrong multiplication problem? You didn't want to do 2 times 20? What else? What else would they might do? Even less, way unsophisticated. What might somebody do? Before I got a chance to do a motor response. Were you going to?
I was thinking if you went out to the whole number of 4, they would have doubled.
Oh. Thank you very much for saying that. If anybody happens to use this curriculum, I don't go out to 4 for a reason. If I go out to 4, how many people can see a kid just doubling? Okay, so yeah, that's a really good point. So we've got all those things. So I might do that, and then we'll get this 40 up here, and then I'll do another one. I might take away a little bit of stuff here. I might say, let's see, we have 0 here and 1. If I chop this up into 4 pieces, everybody, what number goes here? 4. And if I went all the way out here and something weird happened, and let's say I got out here to 6. How many fourths? How many people can see that if I did several examples of these, that some kids would skip count, some kids would count their way up, and some kids would eventually figure out to multiply? Okay, so what I'll probably do with kids, I might say, okay, I'll take a quiet hand really quickly. What number do you think might go here? So we get a bunch of answers up here, and then I'll say, who would like to tell me how we're going to check this out? And maybe somebody else, if they don't, I can say, well, let's see if I was at 2, where am I? If I'm at 3, where am I? And we'll work our way out here and get, what's this, everybody? So, how many people can see that if I did several examples like this, the kids eventually themselves would figure out that you multiply 6 times 4 and get this? How many people, let me see these hands, how many people, some finite number of examples that kids had figured this out. Now, one of the things I want to ask you, and then we're going to talk about this whole, oh, wait a minute, never mind, I want to do one more thing. Kid question. So, let's go back to this one because the picture's better. What multiplication problem did you do to get 40, everybody? So that's 40. Now, I agree with that, but when I was in school, 8 times 5 could mean 2 things. It could either mean 8 5s added together, or it could mean, how many people agree with that? It could be either 5 8s added together or 8 5s added together. I hope I said that right. So, in the context of the number line, is this 48 groups of 5 or is it 5 groups of 8? Talk about that in your table for a second. By the way, that last part, this is exactly what I would ask little kids and say, how many people have an opinion? How many people think it's 6 groups of 7? How many people think that's not even close?
Oh, it's 2 groups of 40.
How many people think it's 8 groups of 5? How many people think it's 5 groups of 8? Who can tell me, if you think it's 8 groups of 5, where is one of those groups of 5? I'll take a hand for that. One of them. Just one of them. Just one of them. Tony? How many people agree there's one of the groups of 5? Where's another one, everybody? How many people agree there's another one? So everybody, how many groups of 5 do I have? 8. How many people think that makes sense? And that's 8 times 5. Okay, we're going to call a big teacher timeout now and talk about, Deb's going to lead this, right? We're going to talk about something we started to call the cycle about what just happened. Okay?
So
You're on.
teacher hats on. I got a little teacher timeout and a big teacher timeout. I'm tagging on to it.
Okay.
Right before he was doing that last processing, we were deciding. He sent you to groups to talk about 8 groups of 5 or 5 groups of 8. How many people remember that? Okay. And then when he brought you out of groups, he asked a very specific question because he was trying to make sure something happened. He asked, who can raise a quiet hand? If you got 8 groups of 5, who can raise a quiet hand and tell me where one of those groups is? How many people recall that? Anybody got a thought about why he would pitch it that way? How many people heard part of that? Well, let's try it again. Are you okay if I put the mic in front? Oh, look, Rick's coming from the other side. Almost got you.
Because you don't want to lead everybody down the wrong path.
That could be one reason, yeah? So he said, if you got 8 groups of 5, he knows which people he's calling on. Can you tell me one of them? Why would he say, can you, so that, you're right. He's getting an answer from somebody that got 8 groups of 5, right? We know we're getting the right answer. Why did he say, can you tell me one of them? Any thoughts about that? Thoughts about that? Tell your neighbor, you got 5 seconds, go. Any speed you want to talk. Anybody got a potential reason why he might have said, can you tell me one of those groups? One of those groups. So let's see, that's Tina, right? No. Tara, I apologize. I just saw the T.
I don't need that.
Well, the camera does, but you don't.
He asked the question one more time.
How come he asked for just one group when he wants the person to respond?
Because there's actually 8 options.
How many people agree with that? And if he gets one person to say one of those options, what did he do after he got? I think it was Tony. Was it Tony that said the one group over here? Is that who it was? Tony said it was between here. How many people remember the first, whoever it was? I don't know. The first person said right there. What did Rick do after that? Who did he ask the question to? One person? How many people think he turned it back to the room? That's what my buddy Fran calls it, turning it back to the room, yes? Okay, so he's getting more people engaged by the way he asked that question about that reasoning. If you were a child, you guys all had it, but if you were a child that didn't have it at that point, maybe you just had your aha right there. Yeah? Okay. That was the littler teacher timeout. Now here comes the bigger one. Okay, so let's look at that whole thing when he first started this thing, and let's see here. When he got out to this place, and then he got to this thing, before he filled in this here, we didn't record it on the board, but he asked you guys to think about something. It was the first time he wrote it. What if I went out here to 8? Something weird happened and I went out here to 8. And he asked you, anybody remember what he asked you next before we started figuring out what was actually there? How many people recall he asked us to think about what kids would guess? Yeah? Okay, so this is the first step that you can use. I got to figure out a board I'm going to write this on. I'm going to write that over there by Bill. A teaching cycle to think about so we can get kids to figure stuff out. And I have a handout with this on it because I can see that blue is less than beautiful. Oh, 2 times today, good for old persons. So you can write this down if you want. Oh, cycle. If you want to, but I have a half handout with this on it, okay? All right. A teaching cycle to get kids to figure it out. My handwriting is lovely, isn't it? I forgot the it out, huh?
If kids figure something out for themselves, think they'll remember it longer than if you tell them? Okay, this is a big emphasis. One is they'll remember longer, and the other is to create a culture where kids think they can figure something out themselves without. Okay.
So step 1 on that cycle, and if you guys want to change the angle of that board, it would be okay with me. I know you can't see it. So step 1 was he had us take guesses, and we said 40 and 13 and 30 and 16, and right, we had guesses all over the place. Yes?
Carrie, were you going to put it on the, whatever that thing's called? What's that thing called?
And then if you just reveal the one I've said, don't reveal the next ones, that'd be cool. So they can come up with them?
Yeah, okay.
There you go.
I thought you were going to write it.
She's got the printed one. It'll be beautiful. We can read it. All right, so then we had step 1, got guesses. Step 2 happened when he said, well, how are we going to figure it out? And then I think he asked you guys to put... But in any case, when she gets that figured out so you can read it, my question to you is, he had you guys think about different ways that kids could get that answer. So he didn't actually make you do it as learners, but how many people remember having that discussion of how many different ways kids could come up with that answer? So let's see, one of them was, the first person said count by 5s. How many people remember that? Yeah, and then, I don't know, what was it, multiply? Do you think there's going to be a kid that really wants to just draw it all the way out and figure it out? And we talked about okay, so those are all ways to do it that I will refer to as have what she's writing right there. Yeah? And it's critical that the long way is based on previous concepts. How many people think Rick had us start when we were whispering, yelling?
How many people? It's only the definition of fraction. That's the only thing, right, that we've said. We defined fraction basically. I mean, I did it with questions, but we defined what a fraction is, and that's the only thing. You watch through this entire fraction lesson, that's the only thing I'm ever going to tell the kids. Everything that comes from fractions, it's not a rule. It's all based on that definition. It's the only thing we have to tell them.
So that was also a previous concept that I hadn't identified that was critical for part 2. Okay, so part 3, so we ended up getting the long way, figuring out what 40 here, and and then how many people could imagine there might still be kids doing it out the long way, figuring out the 24, still skip counting by 4s? Maybe by the third one that wasn't even up on the board, how many people think there might be some kiddos starting to figure out without actually having to draw the picture what the total's going to be as long as they know what the denominator is? How many people there might be some? So there's going to be kids that are actually going to figure out the shortcut way to get it without you. That's what we're trying to do. So we're going for number 3, is we're trying to get the kids to figure out what's the shortcut way to get, in this case, an improper fraction, which we like to call useful fractions, but that's another story. How to get that without actually having to do the whole picture, the long way. They come up with a shortcut. Well, shoot, if you just had thirds and you're going out to 100, all you got to do is multiply the 100 times thirds because you got 100 sets of 3, and right? Yeah, there. That's what you do. What's the shortcut? Okay, and then the fourth one. Now this came at the tail end. Let's see. His question for us to do step 4, before we write step 4, his question was, is it 5 groups or 8 or 8 groups of 5? And how can you tell on the number line? How many people recall thinking about that? So what are we actually doing when we're doing that? Because you guys told him you just got to multiply 8 times 5. That's a shortcut. Step 3 is done. So he asked you, is it 5 groups of 8 or 8 groups of 5? What is he working on right there? How many people think, I heard some people near me as I was traveling by say justification. How many people think he's trying to get us to justify why we're doing 8 times 5? Yeah, so that's the last part, and we're really trying to have kids figure out why that multiplication works all the time, and we're going to tie it back to those previous concepts we just did in step 2. So I don't know how you're going to be writing that, Carrie. That's a big old, you can write it like it's on the paper if you want. What time is it?
So,
oh, that's good.
Common Core, to me, the reason I'm excited about it is it's the first time in my teaching career when there's really seems to be equal emphasis put on skills and reasoning. Okay, the balance in Common Core is going to be what makes or breaks it. If we go one way or the other, it's going to fall apart just like everything else that's happened in the last 20, 30 years. All right, but the balance, and I mean, when you look at that, is it clear that we think the shortcut's important? All right, the kids need to find out that shortcut. That's important. But we want to close the cycle or complete the cycle and get them to go back and see the reasoning behind that. That's what we would like to be able to do on any sort of skill-based teaching that we do. Get the kids to figure out the shortcut and then have them see why it works.
So at this point, we will distribute these little half sheets because we're then going to go down the path of another something you could do in fractions. And now you can have two things going on in your brain. You can be the learner, and you can kind of have your little teacher self thinking, all right, so where in the cycle is he? Is he on step 1? Is he having us guess? Is he on step 2? Are we busy doing it the long way? Is he on step 3? We're figuring out the shortcut. Is he on step 4? Are we doing the reasoning about why it works? You can be thinking about that. So we're going to do this so that you can kind of have a chance to recognize it again, because we didn't even tell you the first time, right? So now you can be watching for those spots. And we may call teacher timeouts to help highlight this. So this is a different thing about fractions, right, Rick? A little further up the grade levels?
A little teacher speech first. One of the things that I want to try and make happen in all this is that addition always means the same thing. Okay? Addition is addition. If I put a plus sign, it means the same thing. It doesn't matter whether it's whole numbers or fractions or integers. It doesn't matter. It's the same thing. And numbers mean the same thing all the time. Okay? So, in this case, when we did this, I'm going to leave this up here. Essentially, when I went like this and said 3/4, how many people agree that that 3/4 represents the distance from 0? Is that okay? So I'm claiming that in this case, a number represents a distance, okay? So I'm hoping, and yes.
How many people agree that Rick did that with his hands when he asked the questions? He said, how far is it from here to here? And you guys said 3/4. Yeah? Okay.
So, lifetime. So how many people remember back to first, second grade? All right?
Couple
Well,
of us. I know, right?
back in first, second grade,
Actually, I do remember second grade. This is why.
when we did, I'll do a little more here. When we did 2 plus 3, how many people remember adding 2 plus 3 on the number line? Just pretend you did if you don't do that. Okay, so this 2 needs to start where? So I have a length from 0. Tell me when to stop. How many people agree that represents a length of 2? And then this length of 3 needs to start where in the context of this arrow? How many people agree that starts right there? And how long should this arrow be? Tell me when to stop. Not there? That's 3. No, all right. How many people agree that's a length of 3? And so how many people agree? There's my answer. So let's just go back and live here a little bit, and then we'll come back to fractions. So let's assume that, because I know we have some primary teachers here, let's assume I had this number line that went all the way out to 10 with any luck. Those are all equal. So
How many
this
people are
is
good at pretending?
0, this is? Everybody, come on.
5, 6, 7, 8, 9.
So, in the context of the number line, how many people can decompose that length of 10 into 2 other lengths? On your papers, see if you can do it 2 different ways.
You guys are being nice troopers, being kids. Thanks.
What grade are we right now? First? First, kindergarten, first-ish? Okay. So I want you to take that length of 10 and decompose it into 2 lengths of something that, yeah. And I asked for 2. You really only have to do 1, but I would probably ask kids to do 2. You don't have to. So, and I just want you to kind of live there for a second. So what might one kid do? Anybody got one? Anybody got one? 5 and 5? Nice. I like that. That's cool. So how many people agree that if I went like this, I went 5 and 5, I get? So what addition problem does that represent, everybody? Who's got another one? Another. Take a hand for another one. Another one. Tammy. How many people have 2 plus 8? So the one length's going to be how much, everybody? 2. Where does it start? 0. And goes over to And the other one starts at? 2. And will it make it to 10 if we do 8? Yes. All right, so sound effects are important. So what addition problem? 2 plus 8. So this is 10 and this is how much? 10. How many people think there's even more of those? Okay, so this is kind of like a fast version, and I'm not saying that you should be throwing out how you teach decomposing, but how many people think this is consistent and reinforces what addition means on the number line? How many people it also gives kids a nice visual for decomposing? I was thinking about something else. I might as well do this too, place value. I was thinking about this in terms of the cycle, and I'm going to, I don't know how long, so I'm going to ask a question, and then I'm going to have you put your teacher's hat on, and kind of like Tony did a while ago, what am I leading to when I ask this question? All right? So I have this giant number line up in my room. I don't know how long your number lines go, but let's say this number line goes all the way to 100.
Whoa.
Is that a big one?
Yeah.
Then I go, well, I'm not going to answer. So let's say that you've got this number line. She beat you to it. Let's say that you've got this number line and it has everything up. And so here's a question for the kids. Now you've got, it's all chopped up, but I go out here to, let's say there's 35 right here. Without looking at the number line, now you're back to first, second grade. Without looking at the number line, take a guess before we look at the number line, how many tens, how many links of 10 you could fit in that. Yeah, in that length of 35. Take a guess. It's hard to guess, huh, because you know the answer. But can you imagine first graders taking a guess? All right. So here's what we do. Now, where am I headed? How many people think I'm headed for place value? So now this is just a new idea. I've never tried this with kids, but I'm just convinced it would work. So I'm thinking, and to think of this in terms of the cycle. Now, if we did this and we went, so we go out, so let's do, tell me when I get to a length of 10. And we do it on the number line. So how many, everybody? 3. There's 3 tens. Well, so if I have 3 tens, am I all the way to 35 yet? How many little spaces are left? Let's count them. Now, here's, go ahead.
Quick.
Yes.
Show on fingers on the cycle.
Oh.
Is he on step 1 or is he on step 2? Show me on your fingers, right here where you think he's at. Having you guess, or he having you do it out the long way based on previous concepts? Show that on your fingers. 1 or 2?
Yeah, we're transition, right? Yeah.
How many people think he's trying to be on 2 because he's trying to build those concepts right about the number line here? All right, unteach your timeout.
Yeah, so, and you know, when we ask those questions, where are you? I mean, how many people see we're probably in transition between wherever it is, 1 and 2 or something like that.
On the doc you can behind.
Up there, we're in transition between 1 and 2. So I guess here's what I'm thinking, and you guys, please, if you try this and you can let me know, just don't let me know if it doesn't work, okay? But what I'm thinking is if I did this with little kids, I don't know how long it would be. I'm guessing it would not take very many problems where if I went out to 73 or something like that, it wouldn't take very many of these examples before the kids said, there's going to be 7 tens.
How many people think that's a different way to get kids to have that aha instead of us telling them what the 7 stands for? Right, so this is a shift, yeah? It's a shift.
And 7 tens, and if you put those 7 tens, how many little spaces are going to be left over? I'm just curious, how many people have taught first grade before? Show me in your fingers how many of those examples you'd have to do before kids would start saying, well, duh, it's just going to be. Show me in your fingers how many examples you think you'd have to do. Most people are holding up just one hand. Somewhere, I mean, I don't care how many, but I mean, I guess, so in the cycle, could you get kids to figure out what the role of that 7 is and the role of the 3 is? All right? And then, you know, they could come back and talk about it. Okay, so a bunch of stuff, and is this consistent with what we know about adding on the number line? Okay, so now you guys just got promoted. to I don't know what grade.
So how many people think we were bird walking down the previous concepts that would have happened even before fractions in lower grades, right? So we were kind of building that so then we can go back with fractions. In the primary grades. Oh, agree. How many people agree we need this to make the progress that we're trying to make? Yeah, wherever.
Yeah, yeah.
Okay.
I want kids to know how to add whole numbers on the number line, because here's what I'm going to do. So we've gone back, whatever grade it is, and I've reviewed, 2 plus 3 on the number line. They know that. So I'm going to say, well, so how many people know how to find a length of 2/7 on the number line? Let me see those hands. How many people, like, you'd chop the whole up into how many pieces, everybody? And then you'd take how many of them? And you draw your line from? All right, so here's what I want you to do. But before you do this, I want you to take a guess for what the answer is going to be. We know how to add whole numbers on the number line. What's going to happen if I add 2/7 plus 3/7? A guess. What guess do you think kids at whatever grade level you teach this, what guess you think those kids might give? How many people can think of a lot of ways to combine those numbers? Here's what I want you to do. Here's what I want you to do. I'll tell you this first. I've come up with an idea the last year or two. I'm calling it my gold standard of teaching. Okay?
This is what you're shooting for.
This is what I'm shooting for. Kids get the correct answer without me showing them a single example. I don't even show them anything. It's not the I do, we do, you do thing. Okay? I know I believe me, I've lived it for a long time. So here's the deal. Here's what I want you to do. Pretend you're a kid, you're good at this, you're adding, and you're good at finding lengths of 2/7 and stuff like that. Live time. I want you to pretend you're kids and draw me a picture of 2/7 plus 3/7 and see if one of those guesses we got is correct.
And the two things we know how to do are, I know how to draw 2/7 on
Yeah.
a number line, and I know how to add whole numbers on a whole number.
Yes.
Okay.
And I do know how to do 3/7 too.
Oh, sorry. Thank you.
Okay. Draw me a picture that you think kids might draw to indicate 2/7 plus 3/7 and see what answer comes up. And I'm just curious. Anybody see a way to get 5/14 on your picture?
Oh, on your picture.
On your picture. Anybody see a way to logically with your picture come up with 5/14? How many people are saying no way? How many people think that's a novelty in itself? Right? Okay. So, well, let's get this up here real quickly just to make sure everybody's cool with this. So if I start here, I'm just going to go 0 to 1. The first thing I need to do is chop this up into how many pieces, everybody? 7. If I do that, perfect. So let's see. Tell me when the first length starts. The first length is how long? 2. And it starts where? 0. Tell me when to stop. So that length represents? 2/7. And the next length needs to represent? 3/7. Tell me when to stop. So that length is 3/7, and our sum is? Now, somebody mentioned over there that kids might stop at 3/7. They might stop there, but that's why when I did the 2 plus 3, this was 2, I stopped at 3 on whole. I'll make that mistake that the kid might make. That's what, I can't remember your name, but when you talk about kind of knowing what mistakes kids make. But the big deal there is, first of all, how many people think at least a significant number of kids, the first time they saw that problem, would draw that picture and get 5/7? Let me see how many people think a fair number of your students would get 5/7. Let me see these hands. Now, come on. All right. Without any examples.
How many people think more students would get it on the second one?
So we do a bunch of examples. And Deb, you're going to call out the cycle back in a minute?
Sure.
Okay. But so a question I've been asking, and I guess I'm going to do this way. I had somebody come up to me in the store the other day and thank me for talking about Common Core to a group of parents. How many people think that was cool? All right, because, and here's what happened. I have to tell you this, and I'm sorry, I've gone almost.
This is the story.
This is a story. This is a new one, though. You haven't heard this. I've pretty much gone a record amount of time without being too cynical yet, but here it comes. Professional development about Common Core, most of it, I'm sorry, I apologize, but most of it to me is wah, 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 you know, and they talk about SMPs, they talk about all this stuff, and nobody knows what the heck they're talking about because, I mean, the people know what they're talking about, but the people listening don't because it's out of context. All right, so this person came up to me in the store the other day, and I was asked to come in Davis, and I live in Davis, and Davis parents they're both the best and the worst thing about Davis schools. But anyway, you know, some people went wah, 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 and I went up, and so here's the example I gave afterwards. I want you to think about this in terms of context. There are two explanations that we could give for that. So 2/7 plus 3/7. What's the wrong answer that comes up a lot? Okay, why don't you add the denominators? Okay, here's two answers. Tell me, this is the question I ask the parents. Which kid do you want? Either as your own kid or if you're hiring somebody, which logic do you want? Here's one reason. Well, when you add fractions and you keep the denominators the same and you add the numerators.
Fractions like these.
Like those, yeah. Okay, if the denominator is the same, you keep the denominator the same and you add the numerators. That's one explanation. That's kid A. Kid B. Third grader told me this. I asked why it's not. The kid said, well, the denominator tells you the size of. Okay, so the kid says this. Well, look, the denominator tells you the size of the pieces. And when you add them together, the size of the pieces doesn't change. But the numerator tells you the number of pieces. So in one place you have 4 pieces, in another place you have 3 pieces, now you have 5 pieces. Who do you want? Kid A, kid B?
Check.
Right? I have heard that explanation several times, almost verbatim in the 3rd grade. Okay. Now, I will say that with this practice, everybody keeps fractions. It's almost impossible. You know, when we went back, we had that discussion about is it more important to know this is called the denominator, or is it more important to know its role? Right? So, when I talk about this, I'm going to be talking about what is the denominator tell me? Number of pieces in the whole. Check.
Check. 1, 2, check. Check. 1, 2. 1, 2, check.
How many people think that's a little jump from the denominator tells you the number of pieces in the whole to the denominator also tells me the size of the pieces in the whole? A little inference, but yeah, how many people think it's important that we get that one? All right. Cool. So, you want me to talk about cycle a little bit?
How many people recognize the cycle in there?
Check. 1, 2.
How many people recognize that you guys at your tables remember it out the long way the first time you did it? Okay, so what we didn't do up here, because you guys did it at your tables, is when we did the second example, after the second example and doing it out the whole thing, I might have said this to the kids. Man, I wish there was a way to figure out this final answer without having to draw this number line. How many people think that would be nice? So for you as teachers, am I trying to nudge the kids from one step to another on the cycle? Use 2 hands to show me which steps am I trying to nudge from one to the next. You might have to use 2 hands to show me between what step and what step. Am I trying to nudge when I say, man, I sure wish this was a way to do this without having to draw this whole number line picture? I'm seeing mostly 2s and 3s. How many people agree? Drawing out the number line picture is the long way, and I'm trying to nudge them to get to a shortcut, yeah? And so that might be a focusing technique under MIF, to focus them on the idea that, oh, wish there was a way to do it without all of this. Then where should they be looking if there's a way to do it without all of this? How many people think the only thing they could look at would be the original problem, which is getting them to think, yeah? Okay, so that's a sneaky focusing technique. All right.
You're live now.
Thank you. Uh-oh, I don't have to yell anymore for the guys in the cameras and the girls in the cameras. Pardon me. She laughed. All right, cool. And so then the last part that Rick was just talking about the kids from Davis, the A kid and the B kid, what step was that? So that's where you're trying to get kids. You might ask them a question like, I might not ask them 2 7s plus 3 7s, but I might say, what if it was, I don't know, some denominator not going to want to draw? 5 12ths plus 3 12ths or something if I don't want to worry about simplifying at this particular grade level. I don't know, something just a little painful to draw, but get them to tell me how that's going to come out. How many people think that's going to be a reasoning thing if we can nudge them a little bit there? All right. So what Rick and I and Carrie would like to know is if there's something coming up in your teaching that you'd like to have some ideas about, how could I do this sort of cycle? So maybe you and a partner, so there's enough for 3 per table, but if you can have a conversation, we're just looking to collect between 1 and 3 cards per table, and at break, we're gonna be looking at these cards. So I'm gonna give you like 5 minutes to jot down. I'm gonna be teaching, and you need to be specific. Like that one was how to add fractions with like denominators. And the one Rick talked about earlier on the primary grades, which was how to tell that the 7 and the 10 spot tells you how many lengths of 10 would fit on a number line, right? So what's coming up in your teaching that you're thinking, oh, I'd like to see how the cycle would work on that, and give us a couple ideas. We're gonna rifle through them, and we're gonna do a couple of them after break, and then give you some time to think about it on your own. So we're mining up for you guys for ideas. Something you wanna say to that about what they write down?
So one thing that I like to say when I do professional development is, over whatever period of time, a big goal for me when I do professional development is get the teachers to recognize in mathematics, because that's what I do, is there's reasoning in that, or there's not reasoning in that. In the 2 7s plus 3 7s, and believe me, don't beat yourself up, because this is how I taught it too. You keep the denominators the same and you add the numerators. How many people like that is sorely lacking in reasoning? Okay? Do you even need to know what a fraction is to do that? Okay? That's how I taught it, I promise. Okay? But so what I'm looking at is that when you look at something, that all you do is if you recognize the difference between reasoning and non-reasoning, that is a huge step forward. And like I said earlier, that doesn't mean if you use just the algorithmic approach and stuff you teach that you're a terrible person. You're gonna do that in most of the stuff you teach for a while, but hopefully over time through PLCs and all that stuff, you'll see how to do it with reasoning. But if you recognize it, so I think I'm gonna add that to what Deb just said. Pick something you're teaching and think about the cycle and think about how would I do that and get reasoning involved in that instead of just the shortcut.
So one of the ones we looked at was, a few people had written rounding, but how do you round to the nearest 10 or round to the nearest 100 without just giving it away and telling the kids how to do it, right? This is a challenge. So we have a couple thoughts about it. They're not beautiful. How many people recognize we just are planning this on the fly in about 7 minutes, right? Okay, so give us a little leeway. We're just, collaborating right now on the spot, ready to go with you. You drew a number line.
Yeah.
Nice.
How many people think that looks like a problem we did earlier? Can somebody tell me one way to decompose that 10 into 2 lengths? One way. We did this before. Go ahead. I'm sorry, Pat.
6 and 4.
How many people agree 6 and 4? So, how many people think if I do 6 and 4, or if I do 4 and 6, how many people think in both cases the sum of the lengths will be 10? How many people think the pictures will look different? So, let's see. And so I'm trying to build off something we've done before. Okay, that was a teacher timeout for myself.
So you were doing previous concepts right there.
Yes. If I did this one, which number goes first?
6.
Tell me, I'm not even going to put stuff up on the board. Number, hash marks. Tell me roughly when to stop. How many people think about there? A little more? How many people think about there? All right. Show me on your fingers in that case, at this point, am I closer to the 10 or am I closer to the 0? How many people agree I'm closer to the 10? If I did it the other way, I did the 4 plus 6, I start with the what? Yeah, I'm sorry. That wasn't a very good question. I start at the 0 and go over to the 4. At that point, am I closer to the 0 or to the 10? 0. So if I did this, if I went, let's say I did 2 plus 8, 8 plus 2. In this one, I start at the 0 and go over to the 2. Am I closer to the 0 or to the 10? 0. And this one, I'd be closer to the 10. How can you just look at that and tell? I didn't even draw the picture. How do you just look at this and tell that on this one, you're going to be closer to the 0?
How many people think that's a little challenging because we just know? So we're trying to put ourselves back in the kids' shoes, right? How are they going to come to that understanding? That's what he's having us pause and do right now.
Well, let me ask that. Yeah.
Having a conceptual understanding of the actual value of what a 2 is, being 2 objects or 2 lengths or something like that versus 8 lengths instead of 8 being just 2 circles that make a symbol.
So I think, okay, so when we get that, which one of these lengths is greater? So how many people on this one, we're not even halfway yet? Because this is bigger? On this one, will we be more than halfway or less than halfway? All right, so let's see, we play with that a little bit. So what if I have another number line and I go out here like this? My pictures are going to be terrible. So let's say this is 0, this is 10, this is 20. I'm going to erase something. I feel like I need about 20 hands here.
Here, I can come up and be some hands.
And this is 30, and we'll call this 40. So if I did 3, if I found 3 on there, which 2 numbers is it between? 0 and 10. Is it closer to the 0 or closer to the 10? 0. How many people think it's closer to 0 for the same reason as we talked about up here? By the way, what piece is missing from the 10? 7. So how many people agree 3 is okay? Well, what if I did 23? What 2 numbers does it go between? 23. Talk in your groups for a second. How would kids decide which one it's closer to? Yeah, what might kids say? Anybody got an idea what they might say? How would they decide which one is closer to?
20 because the 2 goes first.
How many people think 20 because the 2 goes first? That true? So if I think about this, now let's pretend I got that. If I got 20 because the 2 go first, how far is 23 from 20? How many people agree 3? And how far is 20 from 30? How many people think we could go back and use what we know about decomposing tens to answer that question? So if this is 3, then how much is, I apologize for my picture, how much is this over here? 7. How many people have we just taken that back to the exact same question we asked at the beginning? Okay? So if I look at, if I take this number, for example, I'm jumping ahead. We've done a bunch of these examples. Let's say I take the example 76. That's between what 2 tens? And? So this is between 70 and 80. But 80 is 70 plus 10, right? So how many people can tell me what decomposition of 10 problem I could use to tell me which one this is closer to? How many people agree I could look at this distance as 6 plus 4? So 76 is how far from 70, everybody? 6. And how far from 80? 4. Which one's it closer to then? 8. What are we talking about here? If I get around to it? How many people think rounding can be looked at as just taking that distance between the two things you're rounding and decomposing it and looking where you are? Okay, so that's, yes. Yeah, and I kind of danced around that at the beginning when I think, I forget, somebody asked me like it's closer to 2 when I talked about is, and I think in that decomposing, that's one of the things I look at, like 6 plus 4 plus 4 plus 6. I'm sorry? Yeah. Yeah. Yeah, and I think you want to look at halfway and when you're short of halfway and when you're past halfway and that sort of stuff. And that's kind of the whole decomposing thing will get you there, I think. Thought that was going to be a hand up.
How many people can imagine that we could plan when we are going to start saying something about rounding, the word rounding in here? We might plan that. When you're going to drop it, kind of like we planned when to drop numerator and denominator. How many people think we could be purposeful in when we start introducing that? Because he was just saying, is it closer to 20 or is it closer to 30? Somewhere in there we might start saying, are we around 20? Are we around, I don't know, I'm just tossing it out there, right? There might be something to start moving towards that other language, yeah?
If you look at, so we'll move on to the other thing because I think time, but just real quickly, could you use the same thing in rounding to hundreds? Okay, and as you look at this stuff, I mean, I think as you get, it's what's more than half and how far away. But if I look at this, if I look at 176, what are my 200s in between? How far is it from there to there? That's 100, which I could decompose as? Now that may be past where the kids are, but the idea is this more than halfway? Okay? So I think you can look at that rounding thing as just what number is it closer to and whether it's halfway or not, yeah.
What about one that's right in the middle at a 5 or a 50?
You know, I got totally embarrassed in a class one time because I bet nobody in here is old enough to say this, but the rule, what do you do, 15? You round it up? 5 or more you round up? See, I'm trying to find somebody as old as I am, and I haven't found one yet, but maybe I could talk to your dad, Kara. I am sure when I was a kid, by the way, how many people think if you did that, kept doing that all the time, and every time you had 5 or more, you rounded up, you'd have some rounding errors at some point if you did that a lot. I'm sure when I was a kid, and I don't remember which way the rule was, but when it was like 165, you looked at the number before the 5. If it was odd, you rounded one way. If it was even, you rounded the other way.
I saw a nod.
Does somebody recall that?
Nod.
Is that the way it was? Do you know, or? Yeah, but if you think about that, it makes doesn't make any sense as a teacher. But if you look at it, would that negate your rounding errors over? Right, because if you figure half the time the digit before would be odd, half the time it would be even, so your rounding errors would cancel out. If you always round up on 5s, you're going to have rounding error at some point. Anyway, yes.
How many people think if you had a big long list of numbers you were adding and first you rounded, that doing the procedure that Rick learned when he was a little guy would have negated the rounding errors, as he said, right, when you add it all up, because some of them would go up and some of them would go down. How many people think your final answer would be a little bit closer than what we end up doing now is, right? Every time it goes the same direction. So how many people think our answer might be? So anyway, there's different rules for what to do when you're halfway. Because if you do 165 on the number line and you're asking, is it closer to 160 or 170? What's the answer? Right? So then if we're going to round, we have to come up with something. And so our current thing is over halfway, then we bump it up.
And
how
many people are glad you don't have to teach that odd even thing? The other thing somebody mentioned was double-digit multiplication, I think. Is that what?
Yes.
But I want to go back and use this to look at something that I said earlier, that addition always means the same thing. Okay? We talked about addition, that numbers meant what? Do you remember what numbers meant for us on a number line? A distance, right? Addition meant combining those two distances. So numbers for me are still going to mean distance. What happens when you multiply two numbers in? What's the geometric interpretation of that? How many people agree with?
Area.
Is that true? So if I look at this, if I say 3 times 5 represents the area of that rectangle. Can somebody help me with this? I'm teachers here for a second, and then we'll go back to the kids. If multiplication is repeated addition, then where in the heck is repeated addition in that picture? I like that.
I know.
So I got half the room going like this and half the room going like that. That's perfect.
I got it either way, I'm good.
So if I do this, how many people see 3 groups of 5? How many people see 5 groups of 3? If I was working with little kids and they were first doing multiplication, what's the lead into multiplication? And then you do that. Please don't make me skip across the room. Could I? So let's skip count this, everybody together.
3, 6, 9, 12, 15.
Or?
5, 10, 15.
How many people do we get the same thing either way? Okay, so now I have multiplication represents the geometrically of a. Okay, so I would like to, every time, I don't care whether I'm multiplying fractions or what, or 2-digit, I want multiplication to represent the area of a rectangle if I can. Okay, so let's see.
So that's a previous concept you're going to hang your hat on in a minute.
Yes.
Okay.
It wasn't previous till after
Just
I
now.
got it.
Got it.
All right, so let's see. If we do 12 times 3, how many people in here, now just teachers, it's every hand in the room, you guys know the algorithm for this, right? What do you do first?
3 times 2.
3 times?
2.
Is?
6.
And 3 times? 3 times 10 is? I'm going to look at this as 6 plus 10. How many people agree with that? Which? 30. That's better? Which adds up
Didn't
to?
help him out. How come I was the only one in the room helping him out?
I want you to draw me a picture on your papers. Oh, wait, this should represent the area of what kind of thing? Rectangle. Where one side is and the other side is? I want you to edit that picture and see if you can find those 2 multiplication problems in there. This 6 and this 30. You get 2 if you want, go. 2 multiplication problems, there should be how many rectangles? 2? 2 multiplication problems, 2 rectangles? All right. We can make more if we want. This is kind of for you guys, not just kids, because I see some place value in here too. If we look at 2 multiplication problems, there should be how many rectangles, everybody? And did you decompose 3 or decompose 12? We wrote 12 as what? So if I look at this, if I do this semi to scale, this length is, and this length is, and so how many rectangles do I have? What's the area of this one? What's the area of this one? So how many people agree that's 36? Okay, an aside, if I was doing this and I needed this in a place, this 30 represents how many 10s? Where are those 3 10s in my picture? How many people could do that with sign language? How many people are going? There's 1, 2, 3 10s. Okay, so if you needed to kind of re-emphasize place value, if you can get that in there. All right, let's see. What the heck? We'll go right there. Do you want to say something?
Well, I was thinking too, we did this a little backwards if kids hadn't had the algorithm.
Right.
But we know the algorithm, so we put it up there so we could then find it in the picture. But if we were doing this with kids, the picture would be the long way to do it. And then we'd be prompting them with questions about how could you anticipate and then create the algorithm out of that. Yeah, so, and be asking them questions about what size rectangle, how many is it going to have in it, and stuff like that.
Yeah, that's a good. If I was doing this with kids, I'd probably take this picture and say, well, let's cut this into 8 and 4. What's the area of this one, everybody? And this one? What's that up to? Then I'd do another one. What if I make this, like 7 and 5? Would we get the same answer? And then I might ask the kids after these pictures, I'd have this one up there. Which one do you like better? How many people think the kids would say they like that 10? Okay, so that I could sneak it in that way. All right, I'm gonna jump forward and let you guys play with this for a second. So, well, I'll do this like kids. All right, 12 times 13. This should be the area of a what? So if I guess I can get away with this. One of these sides would be, and the other side. Now, if I used what you guys liked me to do before and break off tens, let's see, I'm going to break this here. This would be 10 and 3, so I'll go like that about. And this one would be, how many people think we could use that picture to figure out what that? Deb?
Show me in your fingers how many multiplication problems we should have because of what's telling us in that picture. And the people who are going to do 10 times 10 is one of those. All right.
Okay, so the area of this one as a multiplication problem is what, everybody? That is a multiplication problem. And this one? And this one? And this one? How many people see the 2 times 3 in this problem? How many people that qualifies as the duh question? All right. How many people see the 3 times 10? Now, you guys got to help me. I see the 3, but I don't see the 10. Who can tell me where there's a 10 up there? Where's there a 10 up there? Liz?
With the 12, if you break the 12 apart, 10 and
So now I'm gonna. Does this one stand for 10?
Yes.
Does this one stand for 10?
Yes.
Which one was I talking about? This one? In this one, which 10 are we talking about? This one or this one? How many people think we're talking about the 10 and the 12? So is it this 10 right here? How many people agree that's the 10 and the 12 and that's the 3 and the 13? Okay, so could I ask enough pictures, ask kids to draw enough pictures like this and they get the idea eventually that it's this 2 times this 10 and blah, 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 blah? Okay. By the way, anybody in here ever taught algebra before? I have to ask you this, then I'll quit. If you teach double-digit multiplication like this, and then the algebra teacher a couple years down the road, and the kids are good at this, and they do x plus 2 times x plus 3, this is a multiplication problem, right? So it should represent the... What's one side of the rectangle? What's the other side? How many people think we're going to decompose this? Into what? So if I call this piece X and this piece 3, then I'm going to call this piece and this piece. It would have been nicer if I had been better to scale. So what's the area, what multiplication problem gives you this area, everybody? Oh, yeah, what multiplication gives you this problem? Because this side right here is. So this is 3 times x. And let's see, this side is, and this side is. So that area would be, how many people think your kids are really good at this picture? The algebra teachers are going to tell you, say thank you and take you out to lunch.
So what we were trying to do is go after, how could you conceptually go back to those previous concepts? That's kind of the decision. When you're trying to figure out a way to teach by the cycle, something that you have to teach at your grade level, that step 2, the based on previous concepts, which previous concepts shall I base it on? And then in leading up to that day, you want to make sure they're good to go on those previous concepts. But so we have like 16 minutes before lunch. So you have some table mates, or you may not have the people that you need to speak with at your table. So here's what I want to give you just a little bit of time to think about today. If you have something coming up in this next week or even the next couple weeks, you have some buddies here that are grade level buddies that you could put your heads together and say, all right, we know something's coming up. Here's the topic coming up. On what previous concepts might we be able to ground this lesson, and maybe we'd be able to do the cycle with it. But you could talk together about, on the first one we did, we were using the number line and what's closer, right? On the second one we did, we're using the fact that you could get the area and that helps you answer a multiplication problem. Those are the 2 previous concepts we were hanging those on. So you guys could talk together about what previous concepts. So we're gonna give you a little time today. I know it's short. We're gonna do longer time when we come back the next 2 Tuesdays. So do I need to repitch that question? You want somebody to talk to that makes sense for you to talk to. So if they're not sitting at your table, go find that person or persons, maybe a couple people, and pick a topic that's coming up. What previous concepts? How could we go at this conceptually? And we'll be walking around. You can pick our brains. And then I'll send you off to lunch, and I have to get directions on how to do that. Go. All right. So a little interruption. How many people identified a topic with a buddy around them, and they're having a conversation about what concepts you might be able to build that off of? Okay, few people. How many people have a question in terms of what your conversation is about? Any questions that you have at the moment about what you've been talking about so far in terms of thinking about how to apply the cycle to something that you're going to teach? Questions or yes?
Is that if they haven't had this all the way through, they come into it with, I know the algorithm, why am I going to bother with this? How do we get them to bridge that gap?
How many people feel her pain? How many people live the very same story? Rick has an idea. How many people are happy to have an idea?
I have found something that never works, or rarely works. And that is for me to take the kid who knows how to get the answer and say to the kid, no, you need to explain it to me. I have found that rarely works for me. But what I found pretty much always works for me is to say, suppose you had a friend who doesn't understand why this works. How would you explain it to your friend? Don't explain it to me, explain it to your friend. I have never had a kid balk at that. And I don't know why, but it tends to work. I'm not saying it'll always work, but so far it's worked for me. Just how would you explain it to your friend?
How many people think kids are more likely to want to explain it to their friend? Okay, so that might at least get them to, okay, I see the need to explain it. Then there's the next thing of, I don't know how to explain it, right?
Yeah. See, and I think that's the big thing. Why do I need to explain it to you? But my friend who doesn't, now there's a reason to do the explanation, to explain it to your friend. So now there's a motivation to it, and I think, anyway, that's probably...
And
Yeah, so that's actually the first time I did the addition of fraction thing. That's actually how I pitched the question. I said, suppose you had a friend, and this was just pure luck. Suppose you had a friend that said 2/7 plus 3/7 was, and I asked the kids, what might they say? And they said 5/14. How would you explain to your friend why it's not 5/14? And I even used I forget, I used words that I would Not that they were bad words, but I use.
We are on camera, Rick.
I said, I told the kids, now I want your explanation to the friends. I don't want you just to tell them a rule. I want you to tell them an understanding thing, why you don't, not just a rule. And that's the first time I heard it. That's where I got that explanation with the pieces are the same size.
Can I call on me?
Yes. Since
Deb.
you have a hand up.
Thanks. So up here, we kind of, how many people in the room already had an algorithm, even if it wasn't this one? How many people had an algorithm for 12 times 3? Which is sort of the same scenario you're talking about. Some kids walk in the door already with the algorithm, and they're balking at how to make a connection. And so when we got down to this picture, you might have kids that already have an algorithm. But there were some questions about this. Does anybody remember? I think there was a question about this one and about this one. I don't remember. How many people remember that Rick said, where's 2 times 3 over here? Or how many people can see 2 times 3? And so that might be what you can go to is specific questions about the conceptual long way to do it and ask where those occur over here in the way they already know. So that might be, we had to do that because we all knew the algorithm. We might have to do that with our kids that are walking in the door with algorithms and don't know the conceptual part. Ask those connecting questions, a thought. All right. Any
A
other
good reason
questions?
to move around the room when you teach is so when you look at that picture and realize you wrote too small. Sorry.
Yes. Is it?
And I'll admit on camera that last year when I taught chapter 1, it took me 3 months, and it shouldn't take that long. But the one thing I played with my 5th graders, because let's face it, they all know it all, they should all get hired because you can't teach them anything new, is we would play a game called My Turn, Your Turn. And so they could come in from 4th grade and show me everything that they know, and they already know how to do it, and isn't that great, and isn't that wonderful? And that lasted, in the beginning it was 20 minutes, show me everything you know. And then I would say, okay, my turn, and I'm going to show you something new. Now, how does my turn relate to your turn? So that they can do 27 times 5, and I do it like that, and how are those two related? Now show me that. And they were like, oh.
How many people think that's a strategy to help them build connections between more than one way? Cool.